let us start a new topic today. That is two variable linear models. Okay. So two variable linear model is a very simple and elementary case with single relationship containing two variables. The assumption is that it has two variables and single relationship. So two variables, say y is the function of x, so variables are two, y and x. So y is the dependent variable and x is the influential variable. Because if x is increased or decreased, then the level of y will also increase or decrease. Now simplest form is y is equal to alpha plus beta x. So where alpha is the intercept and beta is the rate of change of x. So if x is increased, then at what rate y will change? And if x is not applied at all, what will be the level of y? And that is reflected in intercept. So it generally happens with some inputs or some explanatory variables, influential variables. Say in crop cultivation, crop production, say x is a fertilizer, and if we increase the level of fertilizer, then level of y will increase. But if we do not apply fertilizer, so we know that based on the fertility of soil and other conditions, so we will get some amount of y without application of the fertilizer. So that is reflected in alpha, that means the intercept. So we'll come later on that the line passes and it starts from an intercept. And when we say linear model, so it is a straight line generally. A line from line is coming as a linear. It is straight. Non-linear maybe curve, maybe quadratic curve or exponential curves. So when you say the linear, it is generally a straight line. Now there are different specifications of the relationships in different ways. Y is related with x. It is not always true that y is the function of beta x, but there are different forms. And the functions of the parameters, that means will be different in different forms. So this is the rate of change, and when it is a power form or exponential, then the interpretation of beta will be different. Now relationships and functions and parameters. Now what are the different forms? So one form, very common form, is y is equal to alpha plus beta x, which we have already talked about. And second is y is equal to alpha e to the power beta x, exponential. And third is y is equal to alpha x to the power beta, that is power form, and y is equal to alpha plus beta to the power x. Now those exponential or power forms are called log linear because after we have to convert them to linear form. So we can convert to linear form by taking log of both sides. So the testing of parameters, because we'll have to take some hypothesis on testing of the parameters, because due to some errors, the parameters may not be exactly what we expect. So the errors must be minimized, and we'll have to test the parameters, whether parameters are significant or non-significant, and we'll have to take the hypothesis or of the parameters tested. Now, why those errors occur? So there are many exogenous and uncontrollable variables. So suppose there will be a human error, that what data has been supplied, or in questioning, suppose a researcher has gone for survey, and you will ask the respondent, but the respondent is telling some some data which are not so much related. It is overvalued or undervalued. As a result, the parameters will be affected. Then sometimes the specification errors are also there, that according to data what we have got, say best fitted is a linear, but we have fitted a log linear. Then also we may not expect the actual parameters. So suppose the rate of change, what we expect, so it's a high rate of change, but there will be change in sign, that it may show that it is declining or it is very low because of this wrong specification of the functions. So, and sometimes exogenous factors, say uncontrollable factors, say weather or climate, even taste habits, which cannot be examined quantitatively. So for these factors also, the parameters will be affected. For example, say consumption of eggs. So even if the consumers, they have money, they have income, but during summer, due to high temperature, the consumption of eggs may be low. So as a result, the parameters will be affected, and we cannot, or if we interpret, so interpretation will not be proper. So like this. Now there will be several errors, maybe human errors, maybe specification errors, and even sometimes wrong interpretations. Okay, so these variables to to capture that error, we generally put an error term in the linear relationship. So y is equal to alpha plus beta x plus u. So u is the equation error as disturbance term. So our aim will be to minimize the u, minimize the error. And another thing is that linear function, that means a line will not pass through all points of observations. It cannot be linear. That's why aim will be to minimize the error terms. Then specification needs assumptions about probability distribution of disturbance. So due to presence of errors, so it needs assumptions about probability distribution of disturbance. So those assumptions are related to mean, variance, and covariance of the error terms. So possible assumptions are, so mean is 0. So mean is 0. Secondly, variance is constant. And third is covariances are 0. So these are the generally the assumptions of probability distribution of disturbance. So other important assumptions are variable ui, that means the error when I ranges from 1 to n, has normal distribution. This is very important. So distribution of ui is normal. So we will discuss in details when we'll come across normal distribution. What is normal distribution and what is the formula, so on. B, covariances of x and u are 0. So covariances between x, that means the independent variable or influential variable, and the error term is 0. Then C, in a repeated sampling, x are a set of fixed values. Okay. Then D, explanatory variables are not perfectly linearly correlated. Of course, in a two-variable linear model, it has no much relevance, but when explanatory variables are many, that means multi-variable case. It is a two-variable linear model. When we will discuss multi-variable linear model, then it is assumed that the explanatory variables will be x1, x2, so on to xn. So all those variables, they are perfectly linearly correlated, and they are not perfectly linearly correlated. So x1 and x2 has no correlation, or x2 and x3 has no correlation, like that. So we call it in econometrics, we call it multi-collinearity. So there is no multi-collinearity in the x variables. Then E, correct aggregation of macro variables. Okay, this is simple. Then aggregation of macro variables should be correct as per rules. Then F, use of unique mathematical form to identify the relationship of variables. So this is also important, that to identify the relationship of variables, the relationship between x and y should have a unique mathematical form. As I discussed earlier, maybe a straight line, maybe a curve, a quadratic curve, or maybe a power function, whatever may be. So it should be relevant to the data. So if data says that it should be a straight line, but we have fitted a power function, so that should not be. That use of unique mathematical form to identify the relationship of variables is important. Then G, all regressors should be included with proper mathematical form for proper specification of the relationship. So this is also important, that mathematical proper, as we said earlier also, that proper mathematical form should be here so that we can specify the relationship in a proper way. So this is all about the assumptions of the linear model, whether it is a two-variable linear model or multi-variable linear model. So these are the assumptions, and with these assumptions we proceed to estimate the parameters. As you said, we have seen in the scatter diagram that y is equal to alpha plus beta x. So alpha and beta, so that alpha beta are estimated properly and tested properly, and they will represent the actual situations. So with this we conclude the assumptions, and we will go to the ordinary least square method. It is known as OLS, ordinary least square method, to estimate the parameters. So next, let us discuss about the scatter diagram. So this scatter diagram has been shown that there will be different pairs of y and x, and which will be plotted in the scatter diagram. Suppose when x1 is this much, 0 to x1, y1 is this much, y1 is this much, y1 is this much, and when it is x2, y1 is this much. So in the first level of xy put, y has increased, but in the next level y has decreased. Now for simplicity, say two observations and have been shown, and there will be other observations like say this and this. So the characteristics of a linear model is that the line should pass through every point, but if it passes through, say, y1, y2, then y3, then y4, and so on, and it will not be a linear curve. It will be non-linear in a zigzag way. So say this is an average line, and aim is to divide this scatter into two equal halves so that the error is minimum. Now here alpha plus beta is unknown and needs to take some hypothesis. So when x1 is this much, y is higher. Now actually it should fall here. So u1 is an error. It did not fall, u1 is an error. So similarly, when we put x2, y should be here, but y is this much. So this is the error. This is y2, and so on. So these errors, they should be minimum. Then this line will be estimated in such a way that errors will be minimum, and it will be divided into two equal halves. So we'll have to take some hypothesis in getting alpha and beta, the unknown parameters. Now yi is equal to alpha plus beta xi. So I ranges from 1 to n. Suppose there are n number of observations, and there will be n number of pairs. So when x1 then there will be y1. When x2, there will be y2. If we remember mapping, and so 1 to 1 pair, so there will be n number of pairs. So expected u is equal to 0. So first assumption is that expected u is equal to 0 for all I. So generally it is mean. And expected ui uj is equal to 0 and sigma u square. So 0 means for I not equal to j, and ij will range from 1 to so on up to n. So these things will be more clear when we'll go and estimating the alpha and beta in the linear model in econometrics. And expected ui uj is a sigma u square. So generally it is the variance, and it is the covariance. It is the covariance. So we say that covariances should be 0 and variance should be sigma square. It is a constant. So we'll come across the the matrix of u and uj, that means error matrix. So in error matrix we'll examine whether the covariances are 0 or not, and whether sigma square is constant or not. So our hypothesis, that means assumptions, tentative assumptions should be there to get a baseline, base P, and the covariances should be 0 and variances should be constant. So alpha, beta, sigma u square are unknown parameters. We may estimate the parameters alpha and beta and test the hypothesis. So we will come across all those, how a hypothesis is tested, and when it is accepted or rejected. So we will discuss this. So please go to the PDF for details, and please share, and thank you very much for watching.